Hi everyone, welcome to tutorial 65 of our introductory Python for image processing tutorial series. In this tutorial, let's do something exciting, looking at plotting using seaborn. And in fact, when I first discovered seaborn, I was super happy, super excited because the way the plots looked were very scientific, very informative, and easy to the eyes too. So let's jump in and start understanding what seaborn is and what it can do, at least look at top 5 categories of plotting: histograms and line plots, bar plots, and a couple other types of plotting using seaborn. Okay, first of all, to get seaborn, all you need to do is pip install seaborn. Okay, pip install seaborn. Once it's there, usually you should not have any issues. I've done this on at least 4 or 5 different systems, so far everything works smoothly. Okay, so once you install seaborn, the way you import it is, again, just import seaborn, and it's customary to import it as SNS. Don't ask me why, but this is what I've seen online, and I just started using the same. Okay, so just like we do PD for pandas, seaborn SNS, and pyplot PLT. So let's go ahead and import the dataset that we have been working with from the last 6 tutorials, which is our data that contains manual versus auto counting of nuclei on 25 different images in 4 sets, so total 100 images. So let's go ahead and import this first so we can again have a quick look in case you haven't watched my previous tutorials. 7 columns. The first one has no name. It's called unnamed 0, and that's automatically assigned by pandas. And I have 4 sets: set 1, set 2, set 3, and set 4, and each set has 25 images, and each image has been analyzed at least once by a person, so I called manual, and these are the counts of nuclei. Manual 2, only 3 images. All of these, they were not analyzed, so let's go ahead and drop that column, or that column is irrelevant for us. And auto threshold 2, auto threshold 3, and auto threshold 4 corresponds to 3 ways of doing automated analysis with different thresholds, obviously. Okay, so now that we understand the data set, let's jump into the plotting part. Let's import seaborn, and let's also import pyplot. Okay, and again, seaborn is using pyplot in the back end, and it's actually adding all this colorful stuff. Okay, so you don't need pyplot, you just need seaborn, but let's go ahead and import it anyway. Okay, so first let's handle the missing values, because when you plot, if you have missing values, sometimes, especially if you're doing some sort of a line plot, and things can look a bit ugly. So first of all, the way, again, to find out if there is anything null is df.isNull. It says all these false and true, but that's not what you want. isNull.values.any, and then it says, okay, yeah, you do have null values. What do you want to do with it? The most useful thing is df.isNull.sum. It actually tells us how many null for each of these columns. So I'm okay with unnamed, image, and autos, but manual, I have 6 missing, and manual 2, 97 missing. We know that. We just had a quick look at the data set. So manual 2 is useless. Let's go ahead and drop it. Okay, so the way you do it is df.drop manual 2, access equals to 1 tells that, okay, we want to drop the column. So there you go, it's gone. Now our data frame has 6 columns. And we still have this issue of 6 missing values from manual. Again, I talked about how to deal with null data in the past, so go ahead and check that video. But for now, let's go ahead and fill all the missing values with a value of 100. Okay, so that's what that line does. So now we are ready. So if you open your data frame, now it should be very clean. You have 4 sets, you have images, and you have all the values, and everything is ready. Let's go ahead and plot it now. Okay, so how do we start? SNS or seaborn has many plots, many ways of plotting. Distribution plot, let's go ahead and do it. Okay, and what do we want to plot? Let's focus primarily on this manual column. And whenever we want to do like 2 columns, we can go ahead and add one of the other ones, but let's focus primarily on the manual. Let's go ahead and do a distribution plot of the manual, and I chose on my IDE to throw plots into the top corner. So there you go. So that's your distribution plot. So this is your frequency plot, in other words. Okay, so this is it. This is how easy it is to actually do your plotting, and now you can do much better control of this. You can actually define your styles if you want. Or let's actually, to this plot, let's add number of bins as 20 and KDE equals to true. And this is our distribution plot, right? I mean, this histogram, this is our distribution plot. By default, Seaborn adds this KDE plot on top of it. KDE stands for kernel density estimate. Think of it as a technique that you can create a smooth curve. But I added some text again. I'll share this Python file with you. Please look at the description down below to find out how to download these files. But KDE estimates the probability density function of a random variable. If that doesn't mean anything to you, go ahead and ignore it. I don't want to make this a plotting a technique tutorial, but this is more of a seaborn tutorial to see how to plot various plots. So assumption is you already know what the plots mean. Okay, so KDE is true. RUG, if you put it to true, it adds like little lines representing each data point. And here I'm going to add my edge color as, I'm going to give my edge color and line width. And once this plot is done, you'll see exactly what we mean. This is our KDE. These little lines are data points representing our RUG. Typically, I turn it off. And then these borders that are enhanced, you see I forgot what the color value of K stands for, but this is edge color that we are actually using to enhance it, and the line width is 0.8, so we can see this in a better way. Okay, now the only thing that I do not like is the range here. I don't want to go from 70 to 130, but we can choose to go from 80 to 120, and that's what we did here. Okay, exactly the same plot, except we chose to go from 80 to 120. So select these two, and again here I'm mixing Seaborn with pyplot, you see, because it uses pyplot in the backend. So in pyplot, I'm setting .x limit to between 80 to 120, and then with Seaborn, I'm doing a distribution plot. So when I select these two and run them together, you should see a plot between 80 to 120. And we turn the RUG off, so it's gone. Okay, so this is our distribution plot, or histogram plot, in other words. Now let's go back, clean things up. Let's clean things up and look at a different type of plot now. Okay, I'll do 4 or 5, and you get the point after that, I hope. Okay, let's read our data again, and let's fill the missing values with a value of 100. We're all set. Now let's do something called KDE plot. We already saw what KDE is. You saw that smooth plot, right? When we did our distribution. So that's exactly what we are trying to do. And when I say shade equals to true, it just fills the shade inside the graph. Let's plot it and look at the plot, and there you go. Very nice and smooth. Okay, this is our histogram plot, except it's a kernel density estimate of our histogram plot. So it tells us that okay, there seems to be a peak in our distribution right here, another peak over there. Okay, now this is only one column. Now let's actually do, because we do have auto 2, 3, and 4. Auto 2 is threshold 2, threshold 3, and threshold 4. So auto 2 underestimates, auto 3 estimates it on average, auto 4 overestimates the count. That's pretty much the difference. Okay, if you want to add all of those 3 plots, just these are individual lines, sns.kde plot. Again, you can do this multiple ways. You can actually do multiple figures, and you can say I want this figure to be here, the other one over there. So you can do all types of stuff. Again, go ahead and look at the documentation, just like pyplots. But if you define them independently, just like pyplot, they're all overlaid one on top of the other. So that's what we're trying to do. Plot 2, 3, and 4, shade them, and when you select all of these, the cool thing is they're all colored in different colors right there. Okay, now obviously you can see threshold 2 underestimating, threshold 3 is our Goldilocks somewhere in the middle, and threshold 4 is overestimating. Okay, these are all our KDE plots. Basic line plots, again, as you can imagine, this is just sns.lineplot. But let's again clear all of our variables and start from scratch. So these lines, like we have done before, import seaborn like before. Now let's actually set style. You can add multiple styles. Again, look at the documentation for what styles can be done. Let's just put a dark grid on top of this image. So that's our style. And now let's actually do line plot. Okay, and the way you do line plot is sns.lineplot. And what obviously a line plot means you have x and you have y. So far we just looked at distribution plots. Now x is our image and y is manual. What is our image? It's nothing but our image number, image 1 2 3 4, and on y we have the counts. So it would be just I don't know, maybe a bit meaningless, but where is the data coming from? Data is coming from my data frame, which is what I've defined here. So seaborn works very well with pandas. And hue is unnamed 0. So if I open this, and if you look at my image number 1 all the way to 24 or 25, they're all part of set 1. Image 26 to 50 are part of set 2, and so on. When I say hue equals to unnamed 0, which is our set name, okay, then it's going to color all set 1 in one color, set 2 in a different color. So hopefully things make sense when we plot it. So let's run all of these lines at the same time and look at the plot. Oh, it's still plotting. Just give it a second. There you go. Okay, so on X we have the image name. We can actually angle the name so you can read it. Right now they are overlaid on top of each other. But more importantly, go ahead and look at this. Again, the plot is, you can define the image size so this doesn't look that ugly, but hopefully you got the point. Set 1 in blue, set 2 orange, set 3 in green, and set 4 in red here. If you do not define your hue equals to something, then everything would be in one color. So this is an easy way of looking at the distributions for different groups within your data. Now let's look at joint plot. This is also very useful because as the name suggests, this is a joint plot of different variables. Again, let's run these lines as usual, reading the data set and filling the NA. And now let's look at the joint plot between manual and auto. Okay, so this is joint plot between manual and auto, and the data is coming from my data frame, and the kind of this plot is a regular REG stands for a linear regression on top of your plot. Okay, so anyway, let's go ahead and plot this. This is again your typical graph, the typical plot of manual versus auto. Think of this as a scatter plot, and this line is our linear regression fitting this data. Okay, so that's what the kind equals to REG stands for, and color equals to R is color this in red, and the one on the top and the side. Okay, so when you do a joint plot, it's actually doing a the bivariate or the two variables plot, and it's also doing univariate graphs. For manual, for x-axis, it's putting that on the top, and for the y-axis, so in this case auto, it's putting right on here. So it's very informative for scientific plotting. This is so rich in information, as you can see right away. Okay, what is the distribution of my manual, what is the distribution of auto, and what is the bivariate distribution when manual is compared with auto, and fitting a line. Okay, now this is a linear regression, but you can do exactly the same joint plot, but your kind is kernel density estimation. Again, when you do 1D kernel density estimation, it's a one-dimensional, but now we are doing a 2D kernel density estimation, which is manual versus auto. So this would look somewhat like a contour plot. Okay, so let's go ahead and plot it, and there you go. Okay, so again, lot of information in this graph, but again, completely depends on your specific application. Hopefully you start to appreciate the strength, the power of seaborn. If not, let's continue and appreciate it further. Okay, let's remove my variables again, start with a clean slate and import pandas and do our thing. And let's also rename unnamed 0 to image set. Again, this is not very intuitive, so let's go ahead and do that. Now let's do something called LM plot. So LM plot is again a linear, it fits a linear. Let's go ahead and plot. It's very similar to what we have done before. except as you'll see, this is a scatter plot where it actually provides a linear regression on top of it. So this is very similar to kdeplot that we have done before. Okay, and it's also giving this uncertainty. Again, go ahead and read up the documentation. I believe this is the 95th percentile at every data point, but I may be wrong. And this fit is of order 1. You can again do of order, I don't know, let's go crazy, order 4. Obviously this is not going to be looking great, but you know, this is overfitting the data, obviously. But if your order is, let's say, quadratic, or you know, to the power of 3, go ahead and define that here. Again, I want to make sure you appreciate how powerful this is, and yet how simple, you know, it is to use seaborn. Now let's do this by hue. Yeah, so far we looked at, okay, all of this data, but we know that the data is divided into set 1, set 2, set 3, and set 4. So let's actually divide this into set 1, set 2, set 3, set 4, and fit 4 linear regressions to all of these 4. Okay, scatter plot and linear regression. So again, we are using our LM plot, x equals to manual, y equals to auto. We are fitting our manual with auto, except in this case, our hue is image set, meaning divide this into image set. And again, let's keep the order to 1. So let's run it, and you should see our data points, again, set 1 in blue and so on, and the corresponding regression lines for these. So again, a lot of this stuff, and again, I should be very frank with you, back in mid 1990s when I was doing my graduate work, I spent almost a couple of months trying to write linear regression code from scratch in Fortran 77, I believe. And all of that is a fraction of a second. Not just all of that, but a lot more is just a fraction of a second right now. So please learn master Python, because it saves you a lot of time in your research. Okay, so one downside, I just mentioned the strength of this, but one downside I should mention is, yes, it's putting all these lines, but there's no way of getting the equation for that linear regression. I mean, it puts this line, but for some reason seaborn is not allowing us to look at what the fitting parameters are and what's the r-squared value is. And you probably know how to do that. There are many ways of doing that in Python. One of the ways is just go ahead and use stats from SciPy, and then apply stats.linear regression onto your data. So let's go ahead and do stats.linear regression. Sorry about that. Stats.linear regression on what? Between manual and auto, right? That's what we're trying to plot here. Let's not divide them by set, but the overall manual versus auto, stats.linear regression. When you do that, it, I believe, sends 4 outputs, or 5. First one is the slope, second one intercept, R value, P value, and standard error. Okay, so you can get all of these, and let's go ahead and print the slope and intercept. And there you go. Our slope is 0.77, intercept is negative 0.89, which does make sense. Okay, and we already looked at regplot. Regplot is very similar to lmplot. I haven't found a difference, or I haven't actually dug into this entire thing, what the difference is between regplot and lmplot, but you can do that if you want. Most of the time I just use lmplot and not much regplot, but the usage is very similar. Okay, let's end this. In fact, before we end this, I know this is getting to be a longer tutorial, but I hope you still are engaged and are learning something from this tutorial here. So let's go ahead and remove our variables and finish this off with a couple more plots. So now let's actually do pair plot. I like pair plots because now you can pick, okay, these are the columns I would like to pair plot, and then plot each one of these against the other. Okay, I think once we plot, it makes sense. Again, data cleanup, the top 4. And then let's do pair plot, where my x variables are auto, all 3 columns, auto 2, 3, and 4, right? And my y is manual. So for each of this x, it's going to plot y, and it's going to show me as 3 little plots. So let's go ahead and do this and switch to our plots so you can see these 3 plots. Okay, so this is what we mean by pair plots. It's a scatter plot, except you're defining 3 different x values and then 1 y value. In this example, you can define multiple x, multiple y, so you have many of these plots, and let's do that in a second. So what we'll do is, again, as before, let's rename this unnamed 0 to image set, so it makes it easy for us. And now let's actually plot. When you do pair plot, previously we gave what x to use and what y's to use. If you do not give any of that, then it's going to pair plot everything with everything. If you have 100 columns, then it is going to be each one of these with other 99. It would be humongous. So please pick for large data frames. But right now, let's just do this. And let's also provide a hue, meaning color them by image set, and drop NA equals to true, meaning if there are any NA values or null values, go ahead and drop it. So let's do that pair plot. It may take a second. As you can see, it's plotting many of these, and we should see a plot any second. Okay, so here we go. Manual versus manual. And diagonally, you should see pretty much the same thing. And here is the pair plot of manual versus auto 2 is right, this one. Manual versus auto 3 is here. So this can be very, very useful. Again, if you are looking at relationships between multiple features, for example, when you're doing machine learning. Okay. Now let's look at swarm plots and finish it off with something cool like a heat map. So let's do swarm plots right now. Remove all the variables and do our imports and cleanup as usual. Import our seaborn. And again, I'm not going to spend too much time on swarm plots. You probably know what it is. So x values, my y value, and where the data frame is. And again, my hue is cell count index in this case. Remember, our cell count index is it a high or is it low? Okay, if you remember that, let's open our data frame. And if you remember this part, low, high. This is our hue that I'm trying to use now. So when you plot it, you should see that, okay, the low values are given in blue, the high values are given in orange, and here are the swarm plots for set 1, set 2, set 3, and set 4. Okay. And you can split it. I think you provide dodge equals to true at the end. And when you do that, it's exactly the same thing except it dodges. So you can see these hue in a separate way. Okay, so finally, let's look at something that we have done in our previous tutorial, which is cross correlation, right? Looking at the correlation between one column versus the other. So let me erase the variables again and start from scratch. Here is everything from data cleaning and renaming the column part of view. And then let's import the seaborn and cross correlation within the data frame. Let's actually look at every row, and then if the data type is equals to int 64, then do dot correlate. Okay, otherwise you'll be correlating manual, manual 2, auto, all of these autos. By default, it ignores text anyway. So in other words, correlate all three autos. That's what this is doing. And let's go ahead and do that. And if you look at our CORR, it's basically a confusion matrix type of output where you see, okay, auto threshold is highly correlated with auto threshold 2 because the value is 1. Here it's 0.61 and then 0.54. Now, you may have this confusion matrix, whether you're doing machine learning or, that's when you call it confusion learning, when you confusion matrix, when you're looking at how many are classified correctly and misclassified. But if you want to do a heat map in seaborn, again, the whole point of doing the correlation is I wanted something that looks okay for a heat map. That's all. The way you do that is sns.heatmap. And what are we mapping? This CORR. And X tick labels is my CORR.column names or columns, and Y tick labels is also CORR.columns. And you'll see that this completely makes sense when you look at the result. Okay, these are the X tick labels, these are the Y tick labels, and these are highly correlated, and you can set a scale 0 to 1 in this example. So these are 6-7 different types of plots in seaborn, and it can do a lot more. And if I really focus on seaborn, this can be 6-7 tutorials. But my intention here is to make sure you know what seaborn is and you know the top 5-6 ways of doing plotting. And hopefully you're motivated enough to dig through this if you're interested in scientific plotting. So thank you very much, and let's cover a different topic in the next tutorial. Until then, do not forget to subscribe to this channel if you haven't already done so. Thank you.